Okay, so we're going to have a look at page 19 of the Probability Methods Walkermaths book. So this page is talking to us about using what we worked out on page 18 to find probabilities. So the whole point in page 18 was from being able to go from x, which is our random variable, whatever we're looking at, and standardizing it to the z score or the z value. So today we're going to have a look at that z distribution a little more deeply. So that's the red one. So let's say that the blue distribution here is our random variable, what the actual thing we're looking at, such as like maybe kiwi weights or the bar of soap weight, and then we've translated that value, that x value, to a z value. So let's say that we had a mean of 8, which I've got over here, and a standard deviation of 2.5, and then we translated that and we wanted to know maybe the area of the amount of people that have a weight between 8 and 12, or whatever the context is. We then translate that 12, which is an x value, over to our z value, which I've found over here, which is something like I don't know, 1.6-ish. At this stage, we can drop the blue graph. We can get rid of this entirely and just focus on our standardized z value. So at this point, all we're doing is looking at our z distribution. And what we're trying to do is we're trying to work out what the area that's highlighted is equal to. So the thing that we need to know is that the total area underneath the curve is equal to 1. So the probability of, so all probabilities are between 0 and 1, right? So if we were to shade the whole area underneath the curve, so I'm actually just going to do that, zhoop, zhoop, see that the probability starts getting closer and closer to the number 1 as we shade the whole area. But what we were looking at, and what we're normally looking at, is between the number 0, oh, I don't actually know what 0 was in the original question. We were looking between 8 and, what was it? 8 and 12, right? So what happens is it standardizes those values, and then all we're looking at is areas between, for example, in this one, 0 and 1.6. So let's go back to the book for a second. So the book's trying to explain to us that if we have half of the area, then it's going to be equal to 0.5. So that seems pretty obvious. If the whole thing is 1 and this is symmetrical, then half of it is going to be equal to 0.5. That's pretty obvious. Where do they get this value from here? So what they actually have done to get that value is they've gone to a z table. And this table is what we're going to start looking at. So this table here helps us to find any probability from our z table accurate to 3 decimal places. So we're going to have to learn how to use this trippy as table, but it's not that hard. So what were they finding? They were trying to find between 0 and 2. So that's between 0 and 2.000. So let's do that. So all you have to do is it automatically finds from 0. So all we need to do is to find 2.0. So where is that? Down here. Oh yeah, nice. 2.0. And then we wanted 2.000. So then we just find the 0 up here, and it's a difference of 0. So we don't need to worry about this bit. So 2.0 is this number here, 0.4772. So that is how, what the heck? They didn't even get the right answer. What did we do wrong here? What did I do wrong here? Are you serious? 2.00. Yeah, what? It should be 0.4772. Well, they think it's 0.4772. 0.475. Well, we're gonna have to flip and check that because I don't like inaccuracies. So let's get it. We'll get it exact. What I'm going to do is I'm going to look at the original distribution. I'm going to change it to a mean of 0. I'm just going to look at the standard one. So that's a mean of 0 and a standard deviation of 1. So this is actually looking at the original, and we want to look between the area between 0 and 2. Oh, let's change this to a number 2. Yes, make B 2. No, not 4, make it 2, please. Now, the area is 0.477249868052. This is the trippy formula that the person had to utilize. They had to make that table using understanding and estimates from this trippy as formula. This is like the absolute crazy thing. You will never need to worry about this. This is like advanced university stuff where you have to actually start studying this distribution, and it is beautiful, by the way. But they have written 0.475, which is actually wrong. So shot to the book. Shout out to Walkermaths for making that mistake. You are not correct at all. It's 0.477. Don't go and make flippin' estimations. From the tables, we also know these values. Well, you clearly don't because you got it wrong, Walkermaths. You kidding me? You numpties. Okay, let's go between 0 and 1 just to see if they are getting that one right. So this one is 0.341. Let's see what they got. They got 0.34. You know what? I'm going to say that that's acceptable. Although, if you're doing 3 decimal places in one question, you should probably stick with 3 decimal places. It's a little bit inconsistent. Yeah, 3DP is what I would suggest that you guys use throughout these questions. So you can use the tables to find these Z values. So you can use, it's on the back, the card page of the book. So let's do between 0 and 1, eh? So it's here. 1 and 0, look at that, 0.3413. That is accurate because we saw it over here, that 0.3413. So that's good, it's accurate. Let's look at the other option. If you have a graphics calculator, you could also find it on here. So the way to find it here is you go to Stat for statistics, then you go to Dist for distributions, that's by clicking the F5, and then we go to Normal, and it's always NCD or inverse. So NCD just means cumulative. It means between 2 values. So the lower value is 0. The upper value we're looking at is 1 in this case. The standard deviation is 1 and the mean is 0. We're looking at the normal. So look at that, 0.3413. So that's how you do it in the calculator as well. I wanted to cover one more thing. Oh, actually, I'll do it when I do the next page. But what if it's something with something a little bit more with more accuracy necessary? So let's look at that. So let's say that B was 1.24. Let's go with that. So between 0 and 1.24, how do we get something like that? So if we're doing that, we go to 1.2, and then we go across to the 4, because that's going to be the next number. So then we go down here, and it's 1.24. So it's 0.3925. And let's check that. 0.3925, absolutely correct. What if it's something even more, needs more accuracy? Let's put a 7 on the end there. This is when things start to get a little bit trippy. So it's 1.247. So to do that, you do the 1.24, so it's 0.3925, and then you need to get a difference of 7, and then we go down to here. Difference of 7 is going to add 13 onto the last 2 decimal places. So see how it's 0.3925. We then add 13 onto the 25 at the end there. So that would make it 0.3938. And let's double check that that's correct. 0.3938. So that's how you do really accurate questions. So hopefully that covers over what we were doing on page 19 of the book.